Hi, 8th grade, Mr. Pastel here, and I'm here to explain your assignment for lesson 2.4, which has to do with newts. Actually, the only thing I'm requiring you to fill out is in part 4, which is the scientific argument. So you're going to make a scientific argument explaining why a newt population has become more poisonous over the past 50 generations. So I'm going to be grading the quality of your scientific argument, which basically comes down to how well do you understand some of these natural selection terms that we've learned so far. You don't have to use all of them. Use the ones you understand. So I'm going to grade you from 1 to 4. So an argument of 4 doesn't need to necessarily have all of them. It just needs to show that you have a good understanding of how natural selection actually works. You would get a 1 if you really don't understand any of these terms and you don't really communicate to me how the newts have changed over time. It's referring to this graph. The argument is referring to this graph that we saw a long time ago. This is super important. So 50 generations ago, this was the data, this histogram, this distribution. Oh, there's Taz. And today, this is what the newt population looks like. And before, there were no snakes, and now there are snakes, which is a pretty important reason for this change, probably. You can also use evidence from a reading here, which is going to load. A reading about newts. Newts have a poison called tetrodotoxin, or TTX. And one guy actually ate one and died, which was not smart. So it explains how TTX became an adaptive trait for the newt, and here's a snake that would eat the newt. And actually, snakes have the ability to smell and taste the TTX poison before they fully eat the frog. So sometimes they can smell it, and sometimes they might do a quick lick taste test and be able to tell if the level of poison in the newt. This diagram's pretty important for understanding this and for your scientific argument. So in the beginning, there was a bunch of newts with some variation, different levels of poison, which is the red dots. So some have a lot of poison, some don't have a lot of TTX poison. The adaptive trait, which is the level of poison, helps certain organisms survive in their environment. The newts with more poison. They're more likely to survive, and they're more likely to reproduce, and they're more likely to reproduce more. And finally, the organisms that reproduce pass their traits to the next generation. So in the long term, you have newts with more poison. You don't have to answer these questions, just the scientific argument at the end. I'm going to go back to the argument. Give you some clues because you're watching this YouTube video, and I thank you for that. So, adaptive trait. What's the adaptive trait that the newts have? It's poison, right? What's the non-adaptive trait? Not having poison. How can we use the word population here? A population of newts in a certain ecosystem they were tracking. What's the environment of the newt? Variation. So the newts had variation in the levels of poison 50 generations ago. They had a certain distribution 50 generations ago, and the distribution has changed over 50 generations. They have a gene, I'm sure, for TTX poison. That gene helps create a protein molecule that actually creates the poison. And the poison is a trait. So I think I mentioned all the words briefly, but I'd like you to use your own words and your own logic, and I'm going to assess the quality of your scientific argument from a level of 1 to 4. So show me what you know. Thanks.